ya.
Efendim?
C dedik ya skaler. O ışık olan C değil mi? Herhangi bir C.
Yok, o C ışığın hızı olarak kullandığımız C.
1 alıyoruz ama dediniz ya onun.
Ya parçacık fiziğin convention. 1 metreyi nasıl uzunluğunu nasıl ölçüyorsun?
Derken?
Mesela diyelim ki C'yi 1 alırsam zamanı nasıl ölçüyorsun? Pardon.
C ile.
Zamanı ben saniye olarak ölçmüyorum. Zamanı ben metre olarak ölçüyorum. Mesela.
Tamam.
Zamanı mesela benim zaman birimim 3 çarpı 10 üzeri 8 metre. Unitim o. 1 saniye değil. Eğer unitim oysa ışığın hızını tanımlamak istersem ne yaparım? Aldığı mesafe 3 çarpı 10 üzeri 8 metre. Ne kadarlık sürede? 3 çarpı 10 üzeri 8 metrede. Böldüm 1 çıktı.
Anladım.
Zamanı saniye olarak niye ölçmem gereksin ki?
Yani zamanın birimi saniye değil miydi?
O convention'lar. Convention olarak öyle seçmişiz zamanında. Mesela atıyorum zamanın ilk ölçüm şeylerine bakarsan aslında ne yapıyorlar? Mum kullanıyorlar mesela. Mumların üzerindeki çizikler var. Aslına bakarsan uzunluğu ölçüyorlar. Ama onun yerine başka bir birim uydurmuşlar. Saniye diye. Uzunlukla karışmasın diye. Ama aslında zaman ölçmek için yaptığımız her şey, neredeyse her şey zaman ölçümüdür. Saate bakıyorum. Saatim saniyeleri gösteriyor. Neye bakıyorum? Ben aldığı mesafeye bakıyorum şu an yani. Şu kolun. Onu ben saniyeye çeviriyorum sonra. Çevirmeyeyim.
Şey dediniz ya, ortadaki sensöre aynı zamanda gidecekler. Şimdi ortadaki sensör tam ortada olduğunu varsayarsak bir uçta olan length contraction'la öteki uçta olan length contraction aynı olacak.
Evet.
O zaman ışıkların gitmeleri gereken yollar aynı olacak.
Hayır.
Neden?
Hareket ediyor çünkü sensörüm.
Sensörüm hareket ediyor, tamam.
Hocam bir şey soracaktım.
Sor.
Hocam dilekçeleri bugün bakacak mısınız?
Cuma
online
bakacağım.
ortamda? Ya AdDrop'ta hani
AdDrop'ta halledersin. Cuma yarına.
yani saati
Bak.
belli mi? Ben ona göre gelsem. Ona göre gelsem saatimi ayarlasam belli mi? Hani öğleden
Yarın-
önce sonra mı bak çıkar diye.
Öğlen çıkacak diye.
Hiç bak şu an.
Bakmadım.
Teşekkür ederim.
Hocam bir şey sorabilir miyim? Hani biz ışık hızından hiçbir şey hızlı gidemiyor dedik ya, information da buna dahil değil mi?
Yani şimdi aslında şu anda ifademiz daha ziyade hiçbir bilgi ışık hızından daha hızlı gidemez.
Kuvvet de dahil o zaman değil mi?
Bilgi aktarmak için kullanabileceğin hiçbir şey ışık hızından daha hızlı gidemez.
O zaman nasıl yani ışık nasıl acceleration'a maruz kalıyor yani sonuçta?
Acceleration'a maruz kaldı.
Hızlı değil yani sonuçta.
Dur, acceleration'a maruz kaldığını nereden çıkardın?
Hocam bir şey vardı, bu iki elektronun arasında bilgi aktarıyorlar böyle, yani şu updown olayları varsa.
Bilgi aktarıyorlar mı?
Yani çok bir şey aktarmıyorlar, sadece birbirlerine...
Az da olsa bir şey aktarıyorlar mı?
Yani en azından diğerinin tersini yapıyor gibi.
Yani diğer tersini yapıyor da
gibi
şimdi
bilgi
bilgi
oluyor.
aktarmak için kullanamıyorsun onu.
İki tane elektronumuz olsa bence yapabiliriz ya. Transistör gibi olmaz mı?
İstediğin kadar olsun, bilgi aktaramıyorsun. O bilgiyi kullanabilmek için yine klasik yöntemlerde arayıp karşı tarafa bir şekilde haber ulaştırman gerekiyor.
Döndü mü diye.
Yani dönüp dönmüyor da, yani döndüğünü bilsen ne hala. Ama sonuçta şunu yapıyorsun, atıyorum 2 tane elektronun var diyorsun değil mi? Sen bunu ölçtün, öbür taraftaki de öbürünü ölçtü. Şimdi o da 2 tane sıkıntı var. Bir, aynı anda mı ölçtü diyorsun? Ama kime göre aynı anda? Hangisi aynı anda ölçtü? Bildiğin tek şey şu var. Onlar daha sonra ölçümlerini kıyasladıkları zaman %100 correlated çıkıyorlar.
Anlık ama bir şey bilmiyorlar yani, sonrasında öyle.
Bilmiyorlar.
Hocam nasılsınız bu arada görüşmeyeli? Onu
İyi.
aslında hatlarınızı sormaya gelmiştim ama baktım muhabbet falan. Çocuklar iyi, çoluk çocuk iyidir umarım.
Valla bir hasta,
Gerçekten.
kış hastalıkları da olacak. Yani standart. O hayatımızın rutini oluyor.
Salgınlar hep klasik söyledim gerçi salgınlar değil mi? Öyle bu arada Arif Emre'nin selamı vardı tekrar
Aleykümselam.
sonra kaldı ama O yaz okulda görüşemedik. Bir daha görememiştim. Onu da söylemek için gelmiştim.
Sağ olasın.
Gerçi okula geldik size konuşmuştur herhalde.
Ne zaman?
İlk dönem
Ya,
için gelmiş hocam galiba bu. Girişimle alakalı.
Ya o zaman görüştük. Dinleyemedim gerçi de seminerine. Geldi
Ben de
doğru.
gidememiştim orada görüşmüştüm.
Yine kız hastaydı diye hatırlıyorum. Bunu ya da bir kız hastayı mıydı? Onu götürmem mi gerekiyordu bir yerlere ne? Yine kızla ilgili bir sebepten dolayı kalamamıştım seminerine.
Geçmiş olsun hocam. Öyleyse hep böyle merhaba demeye gidiyoruz.
Sağ olasın.
Hocam ben şey soracaktım da kitapta bu relativistic mass chapter'ı var da
Ona geleceğiz birazdan.
o hani var mı yok mu diye hala hani şey var mı?
Yani
Yok
şöyle,
diye.
yok. Relativistic mass diye bir şey artık kullanmıyoruz. Anlamı yok.
Hani çünkü daha çok benim momentum'a bir etkisi var.
Olmayabilir. Bakacağız, geleceğiz. Geldikten sonra şey yaparız.
Zamanında ben şey sormuştum size, normal zaman geçmişti ama bu entanglement muhabbetini bir tanesi mesela bir gözlemciye atın. Bir veri site gelirse falan diye. O zaman da demiştiniz correlated çıkacak diye. Peki
Ama
hani
bilgi
bunun
aktarmak için
mekanizmasını
kullanamıyorsun işte.
Bilgi
Anlayabilsek,
aktarmak için değil de
anlayabilsek muhtemelen kuantum graviteye yazacağız. Yani ilginç gelen bir öneri şu, kuantum graviteye uğraşanlarla ilgili diyorlar ki entangled iki parçacık yarattığın zaman aslında o ikisi arasında bir tane wormhole yaratıyorsun. Şimdi wormhole dediğin şey aslında o iki nokta aynı nokta demek. O yüzden yani tam senin gördüğün uzayda belki aralarında çok büyük mesafe var ama o wormhole içerisinden aynı yerdeler.
projeksiyonu gibi bir şey görüyoruz.
O yüzden sıkıntı yok. Nasıl oluyor? Doğrudan etkiliyorlar çünkü aynı noktadalar zaten.
O zaman simultaneously gibi bir şey görüyor. Yani simultane gibi.
Genel relativite işin içine girince biraz karışıyor işler. Yani kime göre, hangi gözlemciye göre, hangi yörüngeye göre işler değişebiliyor.
Çünkü mesela Minkowski'yi 45'i aşmıyorsa o zaman şey oluyor. Yani aynı sırada görüyorlar. O ilginç geldi sadece.
İşte flat uzayda olduğun zaman onunla ilgili bir sıkıntı yok. Ama flat değilsen epey bir fantastik şeyler var. Yani zamanda ileriye giderken kendini geçmişinde bulabilirsin. Buna da bir engel yok. Yani time-like closed loop dedikleri şeyler var. Kapalı bir çember üzerindeyken sürekli ileri giderken bir bakarsın gerindesin.
Tren örneği.
Hı?
Şey gibi mi? Mobius yüzlerine koymuşlar Space'de.
Hiç Mobius çember düşün. Yani şöyle bir yani çember altında giderken kim önde kim arkada. Belli değil ki. Tanımlayamazsın. Anlamı yok.
O zaman ışık mesela biz gemiden ışık hızına gidersek acceleration alsam maruz kalmayız. Işık hızında gidiyoruz. Hani biraz paradoks demiştik yani. Acceleration olduğu zaman da zaman farkıyla dönerken. O zaman alsam dönemeyiz.
Işığı döndürebilir miyim? Boşlukta döndüremem. Döndüremez. Gravite varsa döndürürsün. Ama o zaman zaten buradaki tartışmaların dışına çıkmış oluyoruz.
Duvara çarpar mı? Çarpmaz mı?
Çarparsın.
Ama şimdi ben ışık hızıyla gidiyorum. Benim atomum ona değdiği anda bilgi geçiş olacak. Ama
Evet.
ben daha hızlı gittiğim için bilgiden...
Dur. Bilgiden niye? Bilgiden hızlı gitmek ne demek?
Mesela şöyle düşün. Benim atomum duvara değdiği anda kuvvet uygulayacak.
Tamam.
Ama ben kuvvetten daha hızlı.
Sen kuvvetin bir hızı yok ki.
Ama
Kuvvetin hızından ne kastediyorsun? Tepki hızı ne demek?
şimdi tepki verme hızı.
Tepki verme hızı ne demek? Action, reaction aynı anda olan şeyler.
Aynı anda.
Aynı anda çünkü aynı noktadalar. O yüzden bütün gözlemciler için onun aynı anda demenin bir anlamı var. Derste sor. Hı? Okay, so let's look at this quantity over here. Well, you see, if you look at distances in ordinary space, they are always positive. The distance between two objects can be 3 meters, 5 meters, 10 meters. The distance squared, let's say. 5 meters squared, 3 meters squared. It can never be minus 20 meters squared because all the squares are added. But here we have a minus sign. There are certain quantities which are subtracted from each other. So this quantity, so-called the space-time distance, can be both positive, negative, or even zero. This can be larger than zero. Well, if for two events, this quantity is larger than zero, it just means that their space separation is larger than their time separation for every observer. So this is called space-like separation. Well, if it is less than zero, that means this is larger than this one. It just means that it is time-like. And it can even be zero. Then it is called light-like. You see, for this quantity to be zero, you don't need to have delta x and delta t to be zero. The only thing you need is just delta x minus c delta t. Delta x is either plus or minus c delta t would be enough. And since these quantities, this quantity over here, is always the same for every observer, if two events are separated by a, let's say, a time-like separation, for every observer, they will be separated by a time-like separation. And if for an observer, two events are separated by a, let's say, a space-like separation, for every observer, it will be space-likely separated. Then the question is, for example, given two events, can we find a reference frame in which the two events happen at the same time? Well, if there is such an observer, then for that observer, this delta x is 0. Then this quantity, unless delta t is 0, let's say delta x is equal to 0, but delta t need not be 0. Then for this observer, this quantity is negative. And if this quantity is negative for one observer, it has to be negative for every observer. So if there is a reference frame for which two events happen at the same time, then the necessary and sufficient condition is they should be separated by a time-like separation. So if two events are separated by a time-like separation, then there exists a reference frame in which they happen at the same time. Well, how can we find that reference frame? Well, let's say that you've observed these two events. They are separated by a distance delta x prime and by a time delta t prime in that reference frame, these two events. And so delta x, for the reference frame we are looking for, delta x should be related to this delta x prime and delta t prime through this relation. Oops, sorry, this is v. This should be 0. Which just tells me that v should be equal to minus delta x prime over delta t prime. Well, we will be just going a bit round. Let's say that one event happens at this point now. The other event happens at this point at some other time. Okay? So these are my two events. So I'm measuring x in that direction. So between two events, delta x is positive. Delta t prime is also positive. And this computation tells me that this capital V is negative. But remember what capital V is. Capital V is the speed with which the other observer sees me moving. So if there's a different reference frame, he looks at me and he says that I'm moving with a negative speed. That means that observer, relative to me, it should have a positive speed. So the observer that is moving with that speed, so without the minus sign, in that direction, we'll see these two events to be happening at the same time.
I don't understand why when two events occur at the same time, delta x is 0.
I didn't say that. No, what I'm saying here is there are two events. For one observer, they happen by a separation, they are separated by delta x prime in space and delta t prime in time. So my question is this one. Does there exist another observer for which these two events didn't happen at the same time, but they happened at the same point? So that is why I'm looking for an observer for which delta x is 0, but delta t is non-zero.
So at that frame,
That,
the delta x frame, those events happened at the same
Point.
positions, but not the same time.
yes. Well, the example that we had given before, just imagine me throwing the chalk up. So these are the two events I had. The first event is that I throw it up. The second event is, no, okay, let's do it like this. I just throw the chalk without moving. There are two events. The first event is the chalk passed through this point. And the second event will be the chalk passed through this point. For which observer these two events happened at the same time? Well, for the observer that is moving with the same speed, more or less, same horizontal speed, because if I were moving with the chalk, I just need to throw it up and catch it. For me, they both happened here at like 20 centimeters from my body. They happened at the same point. And this should be my speed.
I'm a little bit confused that are we seeking a third observer that sees the two events, an observer, an initial observer like standing here, and then another observer moving, and the third observer seeing that they happen at the turn time?
No, there are only two observers. We are only comparing two reference frames.
And then there shouldn't be the second observer shouldn't see the V as the same V. I mean, this is a negative side of the V, but at the same speed shouldn't be the same, also the same time, if they are at the same speed.
No, you see, let me repeat what I have done over here. I have two observers. In fact, I start with one of them. There is one observer. He looks at the events around him, and he sees two events. Me throwing the chalk passing through this point, and the chalk passing through this point. So the chalk passing through this point, after some time, the chalk will pass through that point. So these are two events. The second event happens after the first event, and the second event happens at a distance such and such from the first event. So I have this observer. So that observer asks himself a question. Is it possible to find a second observer such that these two events happened exactly at the same time? Exactly at the same point, sorry. At different times, but exactly at the same point. And the answer is yes. The second observer should be such an observer that he should see me, the first observer, as if I am moving with this speed. So for the second observer to see me as if I'm moving with that speed, that observer should move without the minus sign, with delta x prime over with a velocity delta x prime over delta t prime relative to me. So that basically means, in the case of this chalk, that other observer, the second one, there is no third observer, the second observer should be moving in this direction. So that he is right here when the chalk starts moving up. In my reference frame, let's say, when the chalk moves up, he is right over here. And when the chalk passes this point, he is right over there. So these two events, according to that observer, happened at the same point, at different times.
So the position difference is not 0 for the first observer.
Yes. But for the other observer, it is 0.
We said that it is equal to 0.
What is delta x?
Isn't it for the first observer?
The first observer. No, I am this delta x prime. I'm assuming that primes are my coordinates now. This is the other observer. He translates my measurements to his measurements. Delta x is his measurements. And I'm asking this one to be 0. My measurement is delta x prime and delta t prime. They are non-zero. So his measurement, delta x prime, so the velocity that he measures of me, the other reference frame, is negative. He's moving this direction, so I'm moving in that direction.
Wouldn't delta x be non-zero?
Why?
In that case, because I measured you from there, like when you first took up, and you there.
You see, again, I repeat, these expressions, whether you put the prime over here or over there, whether you put a plus sign or a minus sign over there, they're all correct. The problem is how you interpret them. Now, here what I am saying is, let me look from the perspective of the observer who sees those events to be happening at the same time, at the same point. That observer looks at my measurements. My measurements are that those two events happened at a separation delta x prime and delta t prime. I'm the other observer. And then he converts my measurements to his measurements. This is delta x. My question is, his measurement should tell him that those two events happened at the same point. So according to him, the distance between those two events should be 0. That's why I'm equating this delta x to be 0. These delta x and delta t are his measurements. And he's treating me as the other observer. This delta x prime and delta t prime are non-zero.
It's like that you're walking with the chalk. Like.
If the other observer is moving with the chalk,
The other observer like seeing that at the same point.
that the other observer will see them at the same point. That is the result we obtain. But again, the equations themselves don't really mean that much. What is important is how you interpret your results. I said that delta x, I said, okay, delta x will be the measurements of the other observer I'm looking for. Fine, no problem with that. And he said that delta x prime and delta t prime are my measurements. That's what he will use. And he says that v is my velocity measured by him. Then this equation is correct, the result is correct. V is the velocity of me measured by him, because he's treating me as the other reference frame. And so naturally he finds my velocity to be negative, because since he is moving in the positive direction, he will see me as moving in the negative direction. Okay, the other question. We were discussing whether we can change the order of events. Well, let's say, this is case 1. This is case 2. What I'm looking, again, I have two events. Is it possible to find an observer? Let me write it this time. Yes.
Before we started, can we restate what was the v velocity we found? Whose velocity was v?
You see, look at this Lorentz transformation law. You should be careful in interpreting it. There is, basically, we have two reference frames. Let's say the original one and the other one, just for the sake of naming. So this delta x prime and delta t prime is the space separation and time separation between two events measured, let's say, in the other reference frame. And then this v is the speed of velocity of the other reference frame. Then delta x is the space separation in the original reference frame. So you see, the quantities appearing over here, they should be consistent in the sense that if delta x prime is the distance in the other reference frame, delta t prime is the time separation in the other reference frame, then v is the velocity of the other reference frame. Well, you can use the same equation, in fact, saying that delta x prime is the velocity, the space separation in the original reference frame. Delta t prime is the separation of the original, in the time separation in the original reference frame. Then v is the velocity of the original reference frame relative to what? The other one. You see, because this was one of the Lorentz transformations, if you would just invert this one for delta x prime and delta t prime, you would find that delta x prime is gamma delta x minus v delta t. Again, if you, rather than just trying to memorize which one has the prime, which one has the plus minus sign, etc., just note that, let me write it in a slightly different form. This is plus minus v. This is the separation in the primed reference frame. This is the time separation measured by the primed reference frame. This is the velocity of the primed reference frame. And when you put them all here, you get the space separation in the unprimed reference frame. Or this is the space separation in the unprimed reference frame. This is the time separation measured in the unprimed reference frame. This is the velocity of the unprimed reference frame relative to the primed reference frame, and you get the space separation in the primed reference frame.
That v is the velocity of the reference frame, right? Primed reference.
Whichever, you see, the important thing is that you should be consistent. If you are going from reference A to reference B, then this speed is the velocity of the reference A relative to reference B.
So it is the velocity of the frame, reference frame.
Well, I am trying to avoid it because then I would ask which one. I have two of them.
For example, the upper equation, v is the reference frame, the velocity of the prime reference.
Velocity of the reference frame in which you have measured these quantities relative to the other reference frame. Again, it's exactly the same thing over here. If the primed reference frame is moving with a velocity v relative to the unprimed reference frame, that means the unprimed reference frame is moving with a velocity minus v relative to the primed one. So these two equations, although there's a sign difference over there, their interpretation, their significance is identical. Any other questions on that one? Now I will be asking the other question. Suppose we have two events. Is it possible to find an observer for which the two events happened at the same time. So basically what we are at different points. Basically what I am asking is it possible to have delta t is equal to 0 and delta x non-zero? Well, again, if you go back to our invariant separation, if for one observer delta x is 0, and delta t is delta t is 0 whereas delta x is non-zero, then it will be possible. That means this separation is larger than 0, should be larger than 0. Well, essentially, if you just would plot delta x as a function of delta t, delta x and delta t plane, not one of them is not a function of the other one. Let me just put c times delta t. So there's a cone over here. For points in this region, then delta x is larger than, delta x squared is larger than c times delta t squared. They are separated by a space-like separation. If you are over here or over here, that means it's time-like. Yes? You say, the events do not have any speed. The events are fixed points in space-time. What I am saying is, I'm just comparing two events. They might be caused by one another. For example, if one event is caused by the other event, let's say I throw the chalk, and the chalk falls on the ground. These are these two events. Since, as you said, this effect cannot travel faster than the speed of light. If you have two events in which one causes the other one, they have to be separated by a time-like interval. They have to lie either here or here. They cannot be space-like separated. But in general, we are talking about two arbitrary events. One event might be I'm throwing the chalk over here. The second event is the birds outside chirping. They are not related by cause and effect. So their separation can be time-like or space-like or even light-like. So if you are on that line, on those lines, these are light-like. Then we can again ask the question, what should be the speed of this other observer who sees those two events to happen at the same time? Well, we can again go let's say that delta x prime is the separation of these two events that I measured, and then delta t prime is the time separation of these two events that I measured. And let's say that v is the speed with which I am moving relative to that other observer. So the time separation between these two events for the other observer will be this one. This should be 0 for the other observer. And it just tells me that v should be equal to minus c squared delta t prime over delta x prime. Of course, such an observer exists only if delta x prime over delta t prime is less than c. No, sorry, is larger than c. Because only if this is larger than c, the speed is less than c. So this also tells me that, let's say that when the first event happens, you turn on the light. The other event happens before the light reaches that other event. Since light is the fastest thing that we know, nothing can reach the other event if it starts the journey at the position and time of the first event. So the second event in no way can be caused by the first event. So these two events, if there is a reference frame in which they happen at the same time, these two events cannot be caused by one another. Okay, so for these events, only for these events, we can change the order of the events. Because as you go from reference frame to reference frame, you might change delta t. If you have one reference frame that has a positive delta t, if there is another reference frame that has a negative delta t, there should be also a reference frame in which delta t should be 0. Because you can just imagine many sets of reference frames. Initially, delta t is positive. Finally, delta t is negative. And these many reference frames, they differ from each other by a very small speeds. If you have all these succession, delta t for one of them will be 0. Only for those events you can change the sign of delta t, meaning that you can change the order of events. If two events, you see, that basically means that if two events are separated by a space-like interval, their order can be modified. But if two events are separated by a time-like interval, you cannot just change their time separation from some positive number to 0 and then to some other negative values. Well, there's one more thing. Let's discuss that one. About this one, let's look at this time Lorentz transformation once more. Let's say gamma. Let me take out this delta t prime. 1 minus v times v over c squared delta x prime over delta t prime. By the way, this delta x prime over delta t prime need not be the speed of anything. I'm just imagining two separated events. One happens somewhere over here at some time, the other one happens somewhere over here at some other time. They have space separation delta x prime and time separation delta t prime. And let us further assume that these two events are separated by a time-like separation. If I take one of my events to be at x is equal to 0, at t equal to 0, the other event might happen over here or it might happen over there. And then I go to some other reference frame. Well, if they are time-like separated, that means delta x prime over c times delta t prime, absolute value, is less than 1. This is the definition of time-like separation. Delta x prime is much smaller than c times delta t prime. But this means that v over c times delta x prime over c times delta t prime, this is also less than 1. Why? This factor is already less than 1 because we are imagining these two events to be separated by time-like separation. V over c, the speed of any reference frame, should be less than the speed of light c, so this is also less than 1. So basically, for every observer, this quantity over here is larger than 0. If two events are separated by a time-like separation, then for those two events, this factor is always positive, whatever v is. For every observer, this quantity is always positive. But that means that delta t and delta t prime, keep in mind that delta t and delta t prime is the separation in time of these two events. For every observer, delta t and delta t prime has the same sign. So if for one observer, two events that are separated by a time-like interval, event 1 happens before event 2, then for every observer, event 1 happens before event 2. So the ordering of events cannot be changed if the events are time-like separated.
Does this necessarily mean that there should be a causality between those two events?
No, it doesn't mean that there should be causality, but this means that the relativity doesn't violate causality. If event A causes event B, then relativity already tells us that those two events should be time-like separated, because the fastest influence the influence can travel at most at the speed of light. So those two events are time-like separated and their order cannot be changed. For every observer, if for one observer event A causes event B, for every observer event A causes event B. So special relativity at least doesn't violate causality. So yes, simultaneity is a problem. Not a problem. Simultaneity just is a frame-dependent concept in relativity. If two events are simultaneous in one reference frame, they need not be simultaneous in another reference frame. Even their time ordering can change. What this argument tells us is that if for such events are space-like separated, they are in this region, and they cannot they cannot have a cause-effect relationship, because the influence should be, for them to have a cause-effect relationship, the influence should travel faster than the speed of light, which just doesn't exist. If there is a cause-effect relationship between two events, that means those two events are separated by a time-like separation. So for every observer, they will be time-like separated. Furthermore, their ordering cannot be changed. For every observer, their ordering will remain the same. If event causes event B, for one observer, for every observer, event A will cause event B. And so if, let's say, instead of delta x, delta t, if you would imagine your xt graph, this is you. You are right at that point. And all these events over there is your past. They might have influenced you. All those events over here are your future. You can change them. You can influence them. And you have no all the other events, the events outside the so-called light cone, all the events outside the light cone, they cannot influence you, and you have no influence on them. You cannot change them.
Is everything that I can observe during light is light cone?
In your past. Because what do you mean by observing? The light reaches your eye and causes an effect in your eye. It causes some chemical reactions.
Every event that's possible in my lifetime that I can observe is in my lifetime, and all other things that I cannot observe.
Well, you see, keep in mind that this point is also moving in time. So although an event over here at this time is not in your past, it cannot influence you. But for example, a star might start shining at this time, and the light will travel. Some of the light will travel towards you. So it will, when this point moves to this point, it will influence you. Not at this time, but in your future, that light will influence you.
We say that all observable universe is inside the light cone.
All observable universe is inside the past light cone of Earth. But don't think of these things, as I said, as constants. You are moving, you are always at x is equal to 0. In your reference frame, you are not moving, but you are moving in time. T is equal to 0. This is the time t equal to 0. Will be something of your past in 1 second or even less. So you are moving along the time axis. So although this point is not in your past light cone at this moment, in the future it will become in your past cone. So you will be able to observe it, or it will be able to influence you. What do you mean it already happened? According to whom?
I have the information.
How do you have the information?
I will have the information.
You will have the information. Not now. You don't have it yet.
But after that, having this information, then can I still influence the past?
No? No. I mean, you see, once you have the information in the future, it will be in your past. It already happened. So there's no way you can influence it. The light ray. Well, you see, light moves in this direction or in this direction.
That direction, but somewhere in the past.
In that direction.
Yeah, but somewhere in the past.
Okay, this is, you mean here?
Yeah, let's say that.
Okay, let's say that there is this light moving in this direction.
Hocam yok, benim söylediğim şey dışarıdan gelen bir ışık geçmişte bir yerde, yani geçmişte bir yerde oluyor. Dışarıdan geliyor ama gelecekte
Light cannot,
bir yer.
light cannot go like this. The speed of light is constant. It has to go either in this direction or in that direction. It doesn't have any other options. The light cannot move like this. For it to move like this, it means that it moves faster than c. It cannot be. Okay, so we can continue in the break if you like. See you on Monday.